welcome back to episode 8 of the mathsonlinetuition.com videos, where we go through the C1 book. The next chapter, or subsection I should say, of chapter 3 is 3.3, and it reads: you can use the substitution method to solve simultaneous equations where one equation is linear and the other is quadratic. So we're going to carry on with the theme of substitution. In this particular case, we have one linear and one quadratic. As before in episode 7, we had two linears. So here we have, if we take example 3a that is, we have x plus 2y equals 3, and we have as the quadratic x squared plus 3xy equals 10. Okay, so all they've done now is that they've taken x here to be the subject. They made it the subject, so you can say this is 1, this is 2. So they've said x equals 3 minus 2y. Okay, and you can see that they've done that here. Alright, and then they've substituted it in for x in equation 2 squared plus 3 minus 2y y equals 10. Okay, and then they've just factorized, expanded it, so they've attained this, so they've got this particular number of terms here, and again they've simplified it, alright, so that they get this, and then they've ended up with now a quadratic equation in the form of y being the unknown. Okay, so we'll continue from there. Again, the rule was figuring out what two numbers multiply to give 2, but add to give 3, and that is 2 and 1, to give you 2 and multiply 3. So 2y squared plus 2 y, and then you have y plus 1. So on the outside you have 2y, and then we get y plus 1, y plus 1, and then you have 1 here, and then again, if we remember already, we have 1 plus y, y plus 1, and 2y plus 1. Okay, so it's very simple, it's very straightforward. So you've ended up here with all of this being equal to 0. Okay, put a different color. Okay, and then you can see that now y is equal to minus half, or y is equal to minus 1. Okay, and if we plug this in, you find the corresponding x values by substituting the y values into x equals 3 minus 2y. So they just put y equals a half, minus a half in here, or y equals minus 1, and they got their x value. And that's it. That's simple and straightforward. You've got another example to do there, should you wish to try to do what seemingly looks like a more lengthier example, because of the fact that you have the division of 2, okay, and you get a fraction here. Now graphically, the linear equation straight line intersects the quadratic equation curve at 2 points. This curve is a circle. You can learn about this equation in book C2. So this is something for C2, but they just put it here to give you, or try to give you a more holistic understanding. Alright, it is possible, of course, that a given straight line and a given curve do not intersect. In this case, the quadratic equation that has to be solved would have no real roots. In this case, it would be b squared minus 4ac, the discriminant, less than 0. Okay, so that you could have an example, what they mean there, in the form of, so you could have this, and then you could have that being the graph, and a line going like that. Okay, so they don't intersect. Alright, that's just an example of what they're trying to refer to there. And so you've got, again, solve the simultaneous equations. These are questions you can do on your own. Find the coordinates of the point at which the line with the equation y equals x minus 4 intersects with the curve with the equation y squared, etc. So again, for these kind of questions, they're a bit more worded. They're not as basic as this, okay? So, but pretty much all it's just saying to you is find the points, okay, at which this line y equals x minus 4 intersects with this. Alright, and it's pretty much just asking you to solve the simultaneous equations, alright? But this one just worded a little bit more, just to give you a more comprehensive idea of what you're trying to do, essentially, what you're trying to do, okay? So we come on to section 3.4. You can solve linear inequalities using similar methods to those for solving linear equations. You need to be careful when you multiply or divide an inequality by a negative number. You need to turn around the inequality sign. This is very important, okay? And I must make mention of this because it's something that people tend to forget, and sometimes it can be to their own detriment when they're in the exam and they're in a rush and they forget these small, minute points, okay, that can cause them loss of marks. Here's an example of 5 being greater than 2, okay? Now, it says that when multiplying, okay, by negative, or when dividing by negative, the inequality sign turns 180. Okay, essentially the other way. All right. So let's give you an example. 5 is greater than 2, of course. Now multiply this whole thing by minus 2. Get minus 10, and you get minus 4. Now, is this correct? No, because remember, if we have a number line, alright, we can see that once we pass 0, alright, the numbers that got further and further and further down that number line, okay, on the negative side of things, get smaller. And the numbers here, as they go up, gets on a positive side, it gets larger. So we have to turn the inequality around. They give us this. Okay, very simple, just need to remember it. So here's a set of examples that they've given you. So a, 2x minus 5 over 2, 2x is less than 12. Literally all they've done is taken the 5 to the other side. Okay, same thing, they haven't multiplied or divided by anything at this point, and then they divided it by 2. Okay, so there was no negatives involved, you weren't multiplying or dividing by negatives, so everything's all good. 5x plus 9 is greater than or equal to x plus 20. Alright, and they've taken x to the other side. Again, also the technical term here is subtract x from both sides, but I like to think of it as taking it to the other side. It works exactly the same way. Alright, there's never any error in saying that, okay, or doing that particular method, because it's always the same thing. And then again, they've just carried out. Let's go to an example where they actually divide by something negative. C, 12 minus 3x is less than 27. Now here they've taken the 12 to the other side, or subtracted it from both sides, and then you get 15. Now look, they've divided by 3 here, okay, and then look, the sign is flipped. Do you see that? So again, you have to just be careful of these nuances, okay, these subtle differences. That's what mathematics is all about, people. Right, so let's just, okay, let's just go skip these. Now you come on to the point where example 6 is asking you to find a set of values that fall between or respect these two rules, okay, or in other words, that conform, okay, to these two rules. So find a set of values of x for which x minus 5 is greater than 1 minus x, and 15 minus 3x is greater than 5 plus 2x. Okay, now it's not very difficult to do, because literally all you have to appreciate is when you have the two rules after going through the working out, okay, then you can appreciate what the answer is going to be. So in this case it says x is greater than 3, and it says x is less than 2. Okay, so if we had a number line 8, 6, 4, 0, -2, -4, okay, so we said it's greater than 2, sorry, should I put 2 there, alright, and it goes onwards, okay, sorry, greater than 3, okay, that should, imagine that's 3, and less than 2, okay, so we'll just do that, and that's pretty much the answer. One thing just to note here, when you have something that is greater than or less than, and you draw these types of number lines, this looks like a 0, okay, just trying to indicate the point from which the line then diverges from. If you have this case and this case, then this becomes a solid black circle, okay, and you'll see that later on as we scroll down. Alright, so again, same thing. Here you have some exercises, you can do that in your own time. And now we come on to quite a big subsection, which is going to combine some of the ideas we've used beforehand, so hopefully you'll be up to speed. It starts off with solve. To solve a quadratic inequality, you solve the corresponding quadratic equation. Okay, perfect, we've done that. Then sketch the graph of the quadratic function. Okay, perfect, we've done that. Then use your sketch to find the required set of values. Now I have to make a fine point here. If you recall back in the previous videos, we said that the reason why you need to appreciate how to draw the graphs is because later on you're going to start being start being asked how to retract, okay, and extract an answer just by visual observance, okay, and you can see it's started to happen here. So they've given you an example 8, okay, and it says find a set of values of x for which x squared minus 4x minus 5 is less than 0, and draw a sketch to show this. So here we go. So the first thing they've done is x squared minus 4x, okay, equals 0. Now here they've used factorization. Again, we've done so many different methods: factorization, complete the square, and the formula. But in this particular case, factorization is going to do, and you're going to be able to pick up these things, which one to do, which one to use. Factorization is the quickest. You don't need to go through the formula. Right, x equals -1, x equals -5 as is, plus 5 as is given in the answer, okay, and then you know, so you work out the discriminant, okay, so you have to find out what x is, okay, you know that a here is greater than 0, alright, it's 1, so it's greater than 0 just by looking at this point here, okay, you've worked out what b squared minus 4ac is, alright, and so you know that it gives you, okay, 2 real roots, okay, and therefore when you draw it out you'll have something that looks like this. Again, mark your axes, right, and then you can see, so basically anything past this point, okay, insinuates that x is greater than 5, and here x is what? X is going to be less than -1. That's -1. Anything there, and everything that way. So you want to know, okay, what is going to give you values for x where x squared minus 4x minus 5 is less than 0. So we know, because of that, let's take, for example, here, x, let's take, okay, so let's say we assume that this side, okay, respects this rule, respects the rule here. So we say, let's take x equals 6, okay, so 6 squared minus 4 multiplied by 6 minus 5, that's 36, that's 24 minus 5, so we know that that's not going to be less than 0. So this side is straight away cancelled out, okay? What about here? What about if it's, let's say, minus 2? So again, we can say minus 2 squared minus 4 minus 2 minus 5. It's going to give us 4. It's going to give us plus 8. And this is going to give us 4 plus 8. It's going to give us minus 5. Okay, so you're going to have 12 minus 3. Is that going to be less than 0? No, it's not going to be. So what we appreciate then is that we have this line here. Let me use a different color. Use blue. All the points of x on this line here should overlap. Okay, that's just not overlapping. Should be the values that respect this answer. And as you can see here, it says minus 1, okay, greater than, sorry, less than x, or sorry, greater than any x greater than minus 1 but less than 5, and they've drawn like a very light red line to indicate that. So let's scroll down again, another example that you can do in your own time. And then here they have another example. However, you can see that the x squared is negative, the coefficient, so you get that n shape. They've factorized it, they've entered in the values, and then they've taken the values, okay, from one side of x, another side of x, and they figured out that it doesn't respect this answer. Okay, so sorry, I retract that statement. Actually, I believe that it is any value, okay, which is greater than half, yes, greater than half, okay, and less than minus 3, which respects this particular equation being less than 0. Alright, and again they've denoted it using the very light red. And again they have another example. Here they show you two different methods. There are two possible approaches for method 1 depending on which side of the inequality sign you put the expression. Okay, again this is seemingly what we've done. They've sketched it out once they've factorized it. Okay, the negative, the x squared is taken to the other side, so it's negative now. And if you were to take it, all the other terms here to the other side, the x squared would be positive, so you'd end up with this, okay, the U shape. But again, obviously the the roots are the same, minus 2 and 6. That doesn't change. Okay, it's just that now obviously what you're trying to find, the region, okay, of compatibility, sort of changes in terms of the region of compatibility is the same, but what I mean by that is that the y coordinate that corresponds to that x is different. However, that doesn't matter because here we're not worried about the y, we're worried about the x. So you have minus 2 and 6. Okay, and inequalities are the same here. Okay, and on method 2, it says find the set of values of x for which this is the case. So they've taken these terms to the other side, less than 0, factorized it. Okay, and then they've used this table here. So they've drawn up a table. Now, I think this method is something that is probably quite lengthy. I haven't really particularly used this method in an exam, or advise people to use this method in an exam. I think it's just there for you to appreciate a different perspective on how to solve it. But you know, suffice to say, drawing out this table is time consuming. In an exam you don't have the time to do that. You've already got to draw out you know, a graph, and that will give you a better observance. But again, it's up to you how you want to approach it. And then you have an example here, okay, and it asks you to find a set of values for x which respect those two equations. And then you have some exercises that you can do. Once again, we're at the point of the mixed exercises, which combine all the different exercises, so subsections in the respective exercises. Right, summary of key points. Now, once again, I hope we're not going too quick for you. We are just trying to give an overall view of the different subsections. We're not going through a explicit explanation. Okay, so the summary of key points here: you can solve linear simultaneous equations by elimination or substitution. This is the most important thing, I think, from this chapter, and then obviously the rest will just discuss all the various things that we've done. Okay, so thank you very much. That's chapter 3 done. So in our next video we're going to start off with chapter 4. Alright, so do bear with us, and hopefully you can share, like, and also subscribe to our channel for more videos. Thank you very much, and goodbye.